Hello, everybody. Welcome to another edition of the GameLift webinar series. Today, we have a pretty exciting talk here for you. We get to talk with Metalhead Studios about how they got Super Mega Baseball 2 up and running with GameLift, Amazon GameLift. And so my name is Bruce Brown. I am a software development manager here at Amazon. I've been in the software industry for about 12 years now. I was at Xbox at Riot Games. Currently, I'm playing Zelda Breath of the Wild with my son. We both love it. Just such a good game. And Christian, do you want to introduce yourself?
Yeah, so hello, everybody. My name is Christian Zuger. I'm a co-founder and tech director at Metalhead Software. So far we've made Super Mega Baseball and Super Mega Baseball 2, and it's the second one that we'll be talking about here. And my background is mostly in computer science and writing code, basically. So I've been cranking codes for well over 20 years. First starting out sort of as a hobby in high school, writing some simple games, then getting a computer engineering degree, working in the CAD/CAM industry in a while before starting in video games.
Nice.
And the thing that I'm playing right now is Quake Champions, which actually a bunch of us at the office are pretty obsessed with.
Yeah, once a game hits in the office there, you usually get a good group of people playing. Quake Champions, yet another game that's on GameLift. So cool, man. Before we dive into the talk, just a little bit of overview of what we're doing here at Amazon. So we have an initiative that we call Game Tech, and we break it up into 4 chunks. We provide global infrastructure and services. We have pre-built game services and tools, content creation tools like Lumberyard, for example, and distribution and marketing. Specifically, GameLift falls into the pre-built game services and tools bucket. So what are we talking about today? Well, as Christian mentioned, Metalhead is developing or has already released Super Mega Baseball 2, and they built online multiplayer functionality, I think, for the first time. Is that right, Christian?
Yeah, we have really never written any multiplayer code before at all. We didn't really have any experience with AWS or really how to build a backend, nor did we have really any experience with how to write the real-time component of multiplayer either.
Yeah. So we'll dive into that. We'll talk more about what their experience was kind of getting up and running. Then we'll talk about different considerations for multiplayer games when designing game server architecture. We'll dive into that along with the overall architecture that you guys use, not just with Amazon GameLift, but with AWS as a whole. And we'll even talk a little bit about how you can balance costs and latency with those dedicated game servers. So diving right in, Christian, do you want to kind of give us an overview of building multiplayer in Super Mega Baseball 2? Kind of how, where it all began and how you guys got to the point of using GameLift?
Yeah, so our first game, Super Mega Baseball 1, the first release was in December 2014, and then it came out on the additional platform in 2015, but it was a local-only multiplayer game. And we knew at the time that we just didn't quite have the resources to do a full multiplayer game, an online multiplayer game, mostly because we didn't have the capacity or the experience to do so.
Yeah.
But it was the most requested features that our users had. They're like, hey guys, like this is a good game. We really want to play with our friends. Can you please bring it online? So for Super Mega Baseball 2, that was one of the top things that we wanted to do, make sure that we had online multiplayer. The other thing for us that's always a big deal and was a big deal in the first game is fairness and kind of games meaning something. So when we looked at Super Mega Baseball 2, kind of early on, we had decided that basically running dedicated servers was the thing that we wanted to do to make sure that the games are as fair as possible and that recorded match results are sort of under our authority, under the server's authority. And the other thing that we really have is, and I think we'll get into this later, it's on the slide here, is just the way that we deal with difficulty in our game is a little bit different than most games.
Yeah.
So the matchmaking solution that we needed, I think, was quite a bit different from perhaps what other games have. And certainly what we also wanted, because we have a relatively modest player base, we really wanted to have cross-platform play, just to make sure that all the players that do play online have as many opponents to play against as possible. So those are kind of the starting conditions that when we were looking at a multiplayer solution for Super Mega Baseball 2.
Okay, so if I have this right, it sounds like you guys had pretty much no multiplayer kind of online experience building games of that mode. And you guys went, if really like that's pretty impressive. So you went from not having any experience, you decided to kind of throw in, hey, we're going to do skill-based matchmaking. That can be pretty challenging, and you know, get online with dedicated servers. That's pretty impressive. How like walk me through that a little bit. Like what was that process like when you guys were kind of evaluating, hey, like what are we going to do here?
So I think, well, the thing is what we did first is we before really going down the dedicated server route, we had some experiments that we just ran. We was like, well, what's it going to take to actually run the simulation in a networked manner? And before that even is because what we wanted to do was have the entire game be online. So what I mean by that is that any mode that you can play offline, we wanted to be able to play online as well. So people can kind of form parties and they can move through the menus together and do all of those things. So that's kind of what we got up and going first. Is just like, okay, have the clients be able to talk to one another, sort of exchange some bits and all of those things. And once we had that up and running, then we're like, okay, what is it going to take to actually run this on dedicated servers? So the next step was basically to strip down our client and just have like a very small server executable, and being like, okay, where can we run this now? And that's kind of when GameLift came onto the scene, where we started looking at solutions that how can we make the process of spinning up many dedicated servers and managing them in some way as painless for us as possible, because we didn't want to build that entire infrastructure ourselves. And that's when we kind of found GameLift and started going down this path. Yeah,
for sure. So, and if I have this right, you jumped online, you did a Google search, and boom, GameLift. Is that about right?
Yeah, that's right. I was actually aware of GameLift a little bit before this too.
Okay.
It was appealing to me before, but it was closely linked to Lumberyard.
Yeah.
We're not using Lumberyard. We were using a bunch of different tech.
Yep.
But then I looked it up again. It's like, oh hey, there's like the GameLift SDK available, and it's just a C++ API that we can use with whatever we're doing. So I had to look at that, and yeah, it looked really easy to integrate. So we gave it a go, and yeah, we had server processes running on AWS in a very short manner of time. So that was pretty awesome.
Yeah, no, that's quite a good story. So I'll just give a little overview here then of what Amazon GameLift is and kind of what we tried to provide to developers like yourself. So it's a low latency dedicated server service that sits on top of Amazon EC2, and it's built to scale up worldwide. We try and be cost effective, and we also offer cross-platform compatibility. So if you have a game like Super Mega Baseball 2 that would like to launch on multiple platforms, we have that capability. And Christian, as you mentioned before, custom flexible matchmaking solution with FlexMatch. And so that brings us into the next slide, talking about that flexible matchmaking. So this is I think a pretty cool story. You guys identified that you were going to have matchmaking in your game, obviously pretty early. And as a result, we got you into the beta for GameLift FlexMatch as soon as we could. And I think we kind of both helped each other out, if I'm not mistaken. You guys gave us a lot of great feedback during that process. And I think you got to see, hey, yeah, we think this is probably going to work for us. So why don't you take us through like what that experience was like, kind of getting up and running on FlexMatch?
Yeah, it was actually pretty cool for us. So, I mean, before we really knew that FlexMatch was a thing that existed or was about to exist, we had looked at the matchmaking solutions of the individual platforms, and like, we didn't really want to have three separate matchmakers for three separate platforms. And if we did that, of course, we wouldn't have cross-platform matching either. So we quickly ruled that out. So the next best alternative was to basically roll a matchmaker ourselves, which, going back to, we didn't have a lot of experience using like AWS at all.
Yeah.
So we could have probably done it, but it would have probably taken quite a bit longer.
Yep.
So I think we talked to you about this, being like, hey, here's what we're trying to do, and you basically told us, oh, we've actually got something under development right now, or something we're about to develop, which is a cross-platform matchmaker. So I think we sent you sort of here's our dream matchmaker. I sent you a big document of all the things that we're looking for in one. And what came back pretty much did all the things that we were looking for. So that was really cool. I mean, it being a beta product, we ran into some issues along the way, but it was, by the time we shipped, I think everything was worked out. So from our point of view, it was really awesome to basically have an entire sort of entire piece of tech on AWS developed that matched what we needed so well.
Yeah, like it it's a great story from our perspective too, because whenever you're building something new and you're trying to make it a service that you think a lot of customers are going to be into, you really like to get that customer feedback early. And we had some stakes in the ground on some of the things that we thought were going to be important to developers. And when we looked at your doc and saw that come back, it was like, oh yeah, hey, it looks like what we're going to build is kind of on the right path here. And so it seemed like you guys, like you said, there were bugs during the beta. That's what betas are for. And then once it's launched, it seems like you guys had a pretty good experience.
Yeah, that's right. Basically, since we've launched and once the product came out of beta, we have had no issues at all with the Matchmaker. It's been running, I guess, for 2.5 months now, and we've had not a single bug that I'm aware of
nice.
In the matchmaking process. So
that's great.
Yeah, that's been working very well.
Awesome. Well, why don't I give our viewers here just a quick kind of deep dive into what FlexMatch is all about. So if we look at the overall architecture, imagine you have a bunch of different game clients. You might have a group of players that would like to play together. You might have individual players. They're all going to be talking to a game service. And Christian's actually going to dive into the game service backend with me a bit later. Before you get to FlexMatch, you need to do some basic things like authenticate your users against your service, make sure that those folks that want to connect up to your game servers are allowed to. And so like I said, we'll dive into that game service block in a moment. But first, let's talk more about FlexMatch. And so once you have your game clients kind of authenticated against the service, then you can pass those matchmaking requests on to FlexMatch. And FlexMatch provides a rules-based matchmaking system where what we attempt to do is through a rules language that we've developed, provide developers with tools that they can kind of quickly iterate over what the right balance of things like latency and wait time and those general considerations that you have for matchmaking, make sure that you as the developer get a chance to kind of find that right balance. Then what FlexMatch does is it sends any made matches that it finds to our queue service. And what the queue service does is queues are connected to what we call fleets. A fleet is just a representation of your game server build in one of the, in this case, 14 Amazon data centers. And what the queue does is it takes latency information that's passed in to FlexMatch from each of those game clients and then finds the best fleet worldwide in terms of lowest latency to then place that game session. And in addition, what we attempted to do with FlexMatch, and this is something that actually came up during development, was we want to really focus on making that matchmaking pool as large as we can for developers. The more people that you have pulled together, the easier it is to find higher quality matches. And so there's a couple of different approaches that you can take with that. And one is, let's imagine you have a different rule set that you've created for each type of platform that you want to support. So maybe you have a PC matchmaking rule set, a console matchmaking rule set, some hybrid matchmaking set that might be for mobile or console or PC. And then you do maybe even have a specific mobile matchmaking rule set. Wouldn't it be great if instead of splitting your player base across these different matchmakers, just combine them all into one and do that logic within the matchmaking service itself so that all those players can be grouped together, and if they want to opt into cross-platform play, they can. If there are certain platforms that aren't allowed to play with one another, then we can also kind of gate that within the service as well. So that was one of those design decisions that we made actually in response to feedback that we got from you guys. Why don't you walk us through that a bit too, Christian?
Yeah, and this is huge for us. Like I mentioned earlier, one of the things that we're really trying to do is not segregate our user base. For our anonymous matchmate, we basically have one game mode where there's just one button and it says find match. And what that find match button does, it tries to find a fair match to you with the largest player base possible. And that means that the system kind of has to figure out, like, is the match fair, and is it going to be low latency enough across the entire user base of whether they play on PC or any of the consoles that we support. So the way that worked out for us is that the same matchmaking request comes from all the clients, and it goes through the same rule set, and we have basically one queue running in one region, and that queue is hooked up to all of the regions that we support, where servers could actually be spun up. And from the player's point of view, this is completely transparent. So, for example, if somebody in LA hits the find match button, and the system determines that they should be matched with somebody in New York, what happens kind of automatically based on the latency information, it figures out, well, which data center makes the most sense to place this session. And this is all transparent to the user. All they know is that, hey, a game was found for me, and from a skill-based point of view, it's fair, and the rest of it happens automatically.
Yeah.
So there's we don't segregate based on region or based on game modes or based on platforms or anything like that. It's one huge pool of players, and everyone gets thrown into it. So that was one of the most important things for us, because without that, I don't think we would have the user base to support our online match made.
Yeah, I think that's a big consideration, especially with independent developers, where they have kind of a game that might not have millions and millions and millions of concurrent players, but at the same time they do have a passionate player base, and if you can get those players to a point where they're comfortable with the service and with the matches that they're getting, to just trust, hey, you know what, I don't have to select my region up front. Like, the service is just gonna kind of understand where the best place is to place my games, and you know what, like, game experiences that I've have been pretty good. That's what we ask, I think, our players to do. A leap of faith. Hey guys, kind of trust us here. We can send your games to the queue and get you into those fleets, and yeah, maybe you might make a friend halfway across the world that you wouldn't normally play with, but if your latencies can support it, like, let's go for it, so that you can get a better match and you can have more fun with the game, right? Yeah, cool, man. Okay, so now how do we actually do this, right? So the matchmaking rule set, as I mentioned before, is a rules language that we've developed that is just some simple JSON, and I'll step through that now. Metalhead was gracious enough to give us their specific rule set that they're actually using live with the game now. And so at the top here, you just have a little bit of metadata, the name of the rule set, the rule language version in case we need to iterate that on our side, and then you get into the meat of where you actually pass in the player data for your game. And so we expose what we call player attributes. In this case, you guys are using skill, like you talked about before, and tell us a little bit about skill. You mentioned that there's some differences with your game and kind of how you guys do skill-based matchmaking, and why don't you take our listeners through that?
Yeah, so there are basically two main components that go into the match, or three main components that go into the matchmaker, one being skill, one being latency, and one being the platform match. And the skill on our end what we try to do is we try and generate a match that's as fair as possible. And what that means is the skill number should be exactly equal. So what we do is we try to estimate a user's skill. So as they play more and more games, our estimate of their skills gets more and more accurate. But sometimes it's difficult to find an exact match. Again, this is just a function of the player base that we do have.
Right.
But our game has a built-in method. So the difficulty in our game there's no easy, medium, or hard or anything like this. We basically have a kind of a continuous difficulty range from 0 to 100, and it works a little bit like a handicapping system. So if you're talking, say, offline multiplayer, what you might have is a dad playing with his daughter. Daughter's a lot better than the dad at the game. So daughter could be playing at, say, and we call this difficulty ego. So she might be playing at ego 70, dad might be playing at ego 30. And the idea there is that if the ego is set correctly for a player, they will always have a challenging match, in terms of generating realistic baseball scores, getting the realistic number of hits, and all of those things. So what our skill system attempts to do is estimate how good you are at the game and set this ego value for you. So when players play online, as they play and their skill estimate gets updated, they start playing at different ego values. And in addition to this, if the matchmaker can't find an exact match of skill, it tolerates a slight difference, but it accounts for this by having different ego values for the players.
Okay, so that allows you to does that then allow you to kind of I guess have more players be able to play with one another? You're not waiting for skill equals 70 across both players. You can have a wider skill range and kind of handicap that within the game itself.
That's exactly right. We
Cool.
try to minimize this as much as possible.
Yeah.
But if it does happen, it kind of accounts for that.
Gotcha.
Yeah, so that's how our skill update is a little bit different from, or that's how our skill estimation works a little bit differently, I think, from a lot of other games, just because we have that extra variable of the continuous difficulty range. It would be really difficult for our game to have everyone kind of be pinned at exactly the same difficulty.
Yeah.
Just because depending on personal skill, I mean, somebody that can successfully bat at Ego 90, they're going to hit nothing but home runs anyway. So it's really important for us that skill estimate is accurate, and that users play at the ego that we kind of figure out for them. And that's been one of the things that we've iterated quite a bit post launch. We've gotten a lot of feedback from our users about what aspects of it they like and they don't like, and which aspects of it work and don't work. And there's still some things that we're noodling on, but overall I think it's working out pretty well.
Yeah, no, that makes a lot of sense, and it seems like it's just a great way to get maybe a little bit more interaction with your players. What you're trying to balance, just in generally when you're making a rule set like this, is you want, especially if it's skill based, you want players of the same skill playing with one another, but you don't want to have them have to wait 10, 20, 30, 40 minutes for a game. You would like to kind of keep the pace of the matchmaking consistent, and so we'll talk about at the end of the rule set here how we do that a bit. But before we get there, as you mentioned before, the next sections here talk about how you're doing the intersection, essentially between hey, what platforms am I allowed to play on and what platform am I on, and you pass that data in, and we'll show you the rule here in a second that allows you to select a wider band of allowed platforms to play on. Once we get through the metadata that's passed in with the players on the matchmaking request, we just have the teams. In this case, you guys have 2 teams, 1 player each. It's a 1v1 game. And now we can jump into the rules themselves. And so here we'll talk through 3 rules specifically. This is the skill rule, and it might look a little bit Greek, but hopefully once you take a moment to kind of dive in, maybe it does start to look familiar with the syntactical structure that we have, with how you actually tease the skill attributes out of the player attributes, and then use those to do the comparison. Any comment on the rules language, Christian? Was it pretty straightforward for you guys, or was it challenging?
I thought it was pretty straightforward once I looked at the documentation. Just looking at the examples themselves, it's like, okay, this is a little like it, it's like, this is very different from what I'd seen before. Yep. But looking at the documentation, it wasn't really a problem to figure it out, just because the rules themselves, they're not complicated for what we're trying to do. Yeah. So yeah, it really wasn't an issue for us.
Yeah, essentially what we're doing here is you're just comparing the skill of the 2 teams and seeing what the distance is between those skill values. And you start out with a max distance of 1, and we'll talk about later, I think, how you guys relax that constraint over time to try and find that balance between wait time and skill. In the next section here, the next rule is the platform match rule. And here I think what you're doing is you're just comparing the allowable platforms against the set of platforms that the player's on, and doing the intersection. Is that right?
Yeah, so this section solves 2 problems. Solves two very important problems. Yeah. One is what we were talking about before, is the desire to have everyone from all the platforms thrown into one pool to match against. And we're in this interesting situation where we're currently on 3 platforms, and one of the 3, the PC players, are allowed to play against both of the consoles, but the 2 consoles are not allowed to play against each other. And the players can also turn off whether they want to play cross-platform matches in the first place. So it's possible that a player can just say, hey, I only actually want to play against Xbox players if I am on Xbox. Yep. But we still want to throw everyone into the same pool, so that somebody that says, a PC player could potentially be matched against either console. And we don't want to throw them into multiple matchmaking rules. So what we're doing here is just saying, okay, here's my platform, and here are the platforms that I'm willing to play against. And when we generate these matches, if it finds somebody that is close enough in skill, next thing we say, okay, are you actually allowed to play? Are your platforms compatible, basically? Like, does everyone say that you're allowed to do this? And if so, we move on. So this this particular rule is what lets us throw everyone into one big pool from any number of platforms.
Because otherwise you would have to have a separate matchmaker for Xbox, PC, and PlayStation players. Those pools would be segregated. PC players would never know about their Xbox or PlayStation counterparts that maybe they are totally fine playing with. And essentially then what you've done is you've segmented your player base. And once you start segmenting the player base, it's just less players to choose from for, within each segment. So if you can just let the rules handle determining, hey, you know what, like let's start from the biggest slice of the pie that we can, and then narrow it down from there if we have to, you have a larger chance of finding a better match for players. And so it sounds like you guys were able to do that. And I remember you guys came to us with the request of, hey, you know what, we'll do this if we have to, but isn't this something that you guys could just handle in the rules? And we took a look at it and we were like, oh yeah, totally. And so we were able to figure out how to fit the square peg in the round hole from a scheduling perspective, and just knock that guys out for you, or knock that feature out for you guys. Yeah. So, and then the last one, latency. So this is a fairly straightforward rule. The name of it, fast connection. Prefer matches with fast player connections first. And you start out wanting matches of 50 milliseconds or less is essentially what this is saying. Anything else that you want to talk about with this guy before we dive into the expansions?
I don't think so.
Okay.
No, I think that the expansion is more interesting to look at.
Yeah, for sure. And so, what if you find that your matchmaking times are actually pretty long with the rules that you've set? In this case, max distance of 0.1. That seems like a pretty small range. And so, what we've provided from a flex match perspective to kind of address that issue is what we call expansions. And what that does is that allows you to take those values and kind of relax them over time, like relax that constraint, such that in this case, if you've been waiting for 60 seconds, now instead of that distance being 0.1, it's 0.2 and so on. And Christian, I think you guys went through some pretty kind of extensive tuning of this. Am I right?
We did, yeah. So when we first shipped the game, these rules were much more relaxed. So I mean, I guess those those values might be kind of meaningless to the viewers right now. But the 0.1 distance that you saw in the original rule, I think that works out to an ego difference in players of about 1. So we search for a full 60 seconds to try and keep people, to give them as even of a match as possible, and then we slowly expand the rules. As you can see here, after 60 seconds, we kind of double that and we go up. And we originally had actually expanded the search to infinity eventually, just saying that okay, our handicapping system can kind of deal with the difference, but we ended up not liking that. The players ended up not liking it, so we basically as we iterated more and more towards searching longer and generating fairer matches. That's what our player base seemed to like more. So that's what we're seeing here.
I gotcha.
Originally, I think we had pretty aggressive expansions early on. I think after 5 minutes it would expand to infinity, whereas now it only goes up to 0.8 after 10 minutes. And this works because from the get-go, we had kind of said, okay, we would prefer fair matches. So what players can do is they can play the single-player experience while they're waiting for a match. So they can continue their season game or whatever, and they can search for a match while they're playing their season game. And as soon as it finds a match, they're transferred into their match-made online game, and they play that. And once they're done, they can go back and continue the single-player.
Oh, right from where they left off? That's pretty cool. Okay. Yeah,
they have to go through a couple of menus. It's not quite that smooth, but that's the idea, is they can kind of bounce back and forth between the two. And people seem to be doing this. They understand this. It takes a little while sometimes to find a fair match, but it's not a big deal because I can continue my season and things like that.
Yeah.
So that's been working out well for us. Yeah.
And so when we developed Flex Match, I come from a background of working on matchmaking services. And one thing that we know about these systems and these rules is the first rule set that you ship with isn't going to be your last, and you kind of learn your player base over the course of the game, just the course of the game's history. And so it sounds like what you guys found out was, hey, you know what, players are actually willing to wait a little bit longer for a better match. And I think you can correct me if I'm wrong, but the process of actually updating these rules in Flex Match is pretty straightforward, is it not?
It was very straightforward for us, yeah, because all we really have to do is we just, that block that you've got highlighted right there, I would change those values and point our live matchmaker at the new rule set, and that's it.
Yeah, the old players to kind of
we can live update these rules in a matter of seconds. It's really, really easy to
yeah. And then over the course of maybe a few minutes, the old players matching against the old set of rules will kind of die out as they match into games, and then the new rules are picked up in a live way. There's no downtime. You just change your rules on the fly, and players automatically pick those up. So yeah, what we knew was, hey, we want to give you guys the flexibility of kind of narrowing in and tuning and zooming in on what's right for your game. There isn't a one size fits all when it comes to matchmaking for games. There's wildly different games out there with wildly different requirements. Some games need to match players in seconds. Some games, hey, it's fine if we wait a half hour because we're going to be invested in this thing for 2 hours and we want a great match because of that. And so we just try and provide you the tools to iterate over those rules quickly and zero in on what you want. And then if we jump down to the max latency rule, this is the second rule that you guys decided to expand. Why don't you go ahead and take us through that too?
So this one here is a little bit, I don't think this one here has been iterated on quite as much as the previous rule, as the skill-based rule. So that saying is I mean, there's two problems that we're trying to solve here simultaneously. One is that, and it's the corner cases that are interesting, and I think those are the players that benefit most from these expansion rules. A large part of our player base is on the US East Coast, and if you're on the US East Coast, I think it's pretty easy for you to find a match at any time anyway. If you're outside of that, though, it becomes a little bit more interesting because you might just be physically further away from any players that you're matching against. Like if there's a guy in Russia, for example, that's playing, there might not be a lot of people that are geographically close to them right now that are also trying to play. In addition, they also might have a very different skill than anybody else, right?
Right.
So even though eventually there might be somebody else that has a similar skill, and you would pass that rule, it wouldn't be like if their closest data center is Frankfurt, the other guy might be too far away. So over time, we had to relax the latency as well, so that these people that are geographically far away from anybody else eventually get matched with somebody. Yeah. And our game client, so what we try and do is that we put a lot of effort into trying to hide latency in the client, and we can. The game is playable at. I mean, when we did the testing, I always had everything set to a latency of about 160 milliseconds just to test everything with. Okay. And it's perfectly playable at that level, and that lets us do some crazy stuff, like match somebody, say in Germany against somebody in LA. Yeah. And they might get put on a London or an East Coast data center, and then they can have a match. They can have a good competitive match. It won't be as perfect as if their latency was a lot lower. Like you can of course feel it. There's only so much we can do to try and hide that. Right. But it's certainly playable, and they'll have a good time. So that's kind of what the second rule is about: is allowing those people that are geographically further away than the majority of the player base to still find matches and still have a good time with the game. And most people understand this too. I mean, I think people that are geographically far away, if somebody lives in northern Alaska, I don't think they expect to have as good of an experience as somebody that lives, in a major urban hub in the States. Yeah, for sure, man. That makes total sense. One question too, have you found that, players, man, they really love to set the region that they're in, and they want that like 20 millisecond ping and everything else. Have you guys found though that by kind of making the latencies essentially like a black box to the players, have the players been willing to accept that? Like, do they feel like, hey, you know what? Actually, you guys are doing a great job kind of finding us matches that we can play. I actually don't care if I'm playing against somebody, halfway across the world if I'm having a fun time. Is that what your players have been willing to do? We haven't really had any negative feedback about latency specifically. Yeah. I think sometimes of that is that the feedback that you get directly from players is, that the words that are being used to describe the experience doesn't necessarily match the technical problem that's actually at hand, right? Yeah. So we get complaints of like, oh, the game might be laggy or whatever. But that could have many reasons. Like, for example, we have some issues if people are playing on not great wireless connections, for example. Yep. And I think a lot of our problems are coming from that. We have not heard a lot of people complaining about the actual latency, like whether somebody's playing at 20 milliseconds ping or at 100 milliseconds ping. Yeah. There's lots of matches that between East and West Coast and between things, and we haven't really heard too much negative feedback from that. I think the system is working really well in placing people in closed data centers, and so we just kind of wanted to remove that. Again, going back to the player segregation, if we allow players to pick data centers, we gift them the choice to segregate the user base, right?
Yep.
So we tried to remove that altogether, and we haven't really had any negative feedback from that at all.
That's awesome to hear. So I personally could talk about rule sets all day, but we have some other things that I think we want to move on to. Was there anything else that you did want to mention though about the rule sets, or does that pretty much cover it for you?
I think we've covered it pretty well.
Okay, cool, man. So if we move on, let's actually dive into what your overall Super Mega Baseball 2 architecture looks like on AWS. And at first, this might be a little bit overwhelming, but we're going to break it down for you here and just kind of walk through what each of these blocks represents. So you've got game clients, and the game clients have to, as I mentioned earlier, authenticate to your service backend. And Christian, as I understand it, you guys are using Amazon API Gateway to do that initial authentication. So from that first step in the top left there, authenticated matchmaking requests, those go to Amazon API Gateway. Is that right?
Yeah, that's right. And so that was another very important piece for us. All the platforms, this solves two problems for us. We basically have to authenticate any players that are incoming.
Yep.
So we don't want to allow pirated clients to be able to use our backend that we pay for. And just from the Xbox and PlayStation's point of view, like we have to authenticate everything. So what we can do is every platform kind of has a different way of authenticating, but the way it ends up working is that we basically can just write a custom piece of code, basically a Lambda that we wrote in Python, that any incoming requests, it looks at the incoming authorization token, and depending on the platform, we may have to decrypt it, or it makes calls back into the third-party services to authenticate a given user. And if we don't like what we see, if the incoming user request is no good, we can shut them down right there. So there's no cost that's incurred on any of the other services if the incoming player isn't actually legit, doesn't actually own the game, is currently banned from playing online. So that's also where if parental control settings prevent somebody from playing the game or anything like that, we check those things there. So
nice.
Unless the player in fact owns the game and in fact is allowed to play online, they kind of get shut down at the Amazon API Gateway level.
Got it. Yeah, and the nice thing about that service is that allows you, like you said, to kind of write your code against one service to then do the logic to handle the different backends from the different platforms that you might have to talk to, whether it be Steam or Xbox or PlayStation. And so once the requests are authenticated, then it goes to the AWS Lambda service. Lambda is pretty slick. It's just a serverless architecture such that you submit code to the cloud, and then AWS Lambda figures out how many machines it needs in order to be able to support that bit of code based on the traffic that's coming in, and it will automatically scale to kind of adjust there. What do you guys use Lambda for?
So we use Lambda we use it for almost everything.
Nice.
And so we made that decision because one thing I forgot to mention earlier is we knew reasonably early on that this game was going to launch into the Xbox One Gold program. Which is a bit of a scary prospect. that meant day one there's potentially going to be millions of clients that run this thing. So
good problem to have, but
but it was kind of scary because we didn't, like I said before, we had no experience with things. So when we looked at the solutions available, one of the things that we looked at most was how does it scale without us having to manually do it? And so that's why we chose Lambda, because it just seemed like we could write all our logic, and beyond that, if you set the knobs right, like it'll scale up and it just won't be a problem at all. So the kind of things that we do inside of there is actually our entire logic for our ranking system runs inside of there. Any requests that we make to GameLift run in there. So the way that would work is that there might be a REST call that we make. A client says, okay, I want to actually find a match. So we call an endpoint in API Gateway, which calls to Lambda, which is just a simple Python script that then forwards a call to the appropriate GameLift API. So that kind of lets us just have these relatively simple functions that can be invoked either once or millions of times at the same time, with it really not making any difference to us. Like we don't have to worry about the scaling at all.
Nice. Yeah, and I think that's the main advantage of Lambda is when you don't know how to forecast those costs up front, you just like upload your code and boom, they'll figure it out for you. So
and there's one thing that I should mention there too. There was one problem that we have, which where Lambda was insufficient, we do have a dedicated EC2 instance running for a problem, and it's basically at the end of the way our matchmaking system works is every week it resets internally, and it just turned out that Lambdas can only run for so long. So if you have a process that say runs for 10 or 15 minutes, that doesn't work. So originally we had it running in Lambda, and then we shipped, and things started taking longer than we did, but it really wasn't that big of a deal. All I ended up doing is just take an EC2 instance, install Bodo3, get all the credentials on there, move my Python scripts, which were like all I really had to do was just not have the Lambda entry, but it's exactly the same code that we used to have running in Lambda, and I just set up a little scheduled task to run on the EC2 instance. That was that.
I gotcha.
So it was super easy to take a thing that used to run in a Lambda to run basically on a dedicated EC2 instance for something that just took too long.
Nice. And you know what that fixed cost is, you know how long it's going to take to essentially re-kick that Lambda system, and so that one EC2 instance isn't a big deal, it sounds like.
Yeah, it's almost free.
Nice, cool. And so you also looks like you persist some of your matchmaking data into Amazon DynamoDB. DynamoDB is a scalable NoSQL based table storage structure. And so yeah, why don't you guys tell me just a little bit about how you're using Dynamo and how that's working out for you too.
Yeah, so again, we chose Dynamo for simplicity reasons. We hadn't worked with NoSQL databases before, but the appeal to me was that it promised constant access times regardless of table size, and we didn't have to provision servers or anything like that. It's just you pay for what you use, and you're promised constant access times. So it's okay. I know up front, like I said, it's because we're launching into gold. There's going to be like our user tables is going to grow to millions of records pretty quickly. So we basically store everything about our entire. All the data that we store is in Dynamo. So user records, like the current state of the matchmaking system, sort of intermediate state for matchmaking tickets, intermediate state for arranged games. Everything we just kind of stash in Dynamo. It's really easy for us to query data from Dynamo from our dedicated servers, and it's really easy to query or stash data from the clients into Dynamo. So we just kind of use it as a staging area for data that either our servers or our clients or any of the infrastructure around it needs. Like if a Lambda that's trying to fulfill a matchmaking request requires a bit of extra data that perhaps the server needs later or something like that, we just always stash it in Dynamo. We just kind of use it as a staging area like that.
Okay, cool.
So it's both a persistent store long-term and kind of a short-term store.
I gotcha. Okay. So, and that sounds like it's working out pretty well for you guys. And so if we then like follow that flow from the Lambda into FlexMatch, you know, we talked about that earlier, a couple slides previously, dove into the architecture there. There's two paths here. The right path goes and actually sends off a notification through the Amazon simple notification service once the match is made, and it has other notifications that it can send during the matchmaking process as well. And so if you can quickly go over how you guys are using Lambda and SNS as well to kind of monitor the progress of matchmaking, that'd be great.
Yeah, so what happens is the client makes a request. It says, okay, we're going to try and start matchmaking. And that's really all the client does. Based on the user ID that's been passed in, we query Dynamo. We're like, okay, what's this user skill value? What are latency values that are known for this guy? And we pass this off to FlexMatch to start the matchmaker. And what happens then is that it periodically updates. Like if something relevant happens, in the matchmaker, like it has found a match or it has timed out or anything else like that, it sends notifications via SNS, which we then process in the Lambda and just stash in Dynamo again.
Cool. Okay.
And what the client does is as soon as the matchmaking request has been started, it basically makes another request where it just polls the Dynamo database for the update of the matchmaking request. And so the decision we made there was, well, if there are a lot of people searching simultaneously, then matches are going to be a match is going to be found quickly. So the amount of polling that we do is going to be short. And if there are only a few players that are in, then they're going to be polling our database forever essentially, but it doesn't matter because there's so few of them that the cost is still very low.
Nice.
So cost is either low because we don't poll much, or it's low because there's not a lot of people doing the polling.
Yep.
And what we end up doing is we just Lambda polls Dynamo every second, and that gives us really quick response times. I think that the turnaround from flex match actually making a decision, oh, a match has been found, and to go through that bottom right leg there through SNS through Lambda into Dynamo is very quick. And the polling from the Lambda to the Dynamo DB arrow there is, like I said, it's about 1 second. So
yeah,
in the most ideal scenario, like for example, if there are two players that hit the find match button at the same time, if they have similar skills and are close together physically, I think the entire system returns in just a handful of seconds.
Yeah, that we try to make sure that your matchmaker is going to determine some amount of wait time for players and just with the rules that you select. But we try and make sure that once matches are found within the back end, a second or so of overhead is what we are hoping to kind of add there at the most to the process. And so once you've gone through and match has been found, you have players that are ready to go. Q's has gone and found the fleet. We then follow the left path there where a game server is spun up via that Q service that I talked about earlier. The connection info is then sent back down to the players so that the players can know which game server they're going to server instance they're going to connect to, and then they're off and running. And the cool thing there that happens is GameLift is essentially out of the picture at that point. We aren't introducing additional latency or overhead. The players are just talking to that dedicated server and are ready to go. And so if we then want to just talk about kind of one more thing that you guys are doing here, you guys are doing some status checks, right? With the matchmaking process, just to make sure that somebody didn't go off to the bathroom when the match popped or didn't get disconnected, to make sure that they're still there and present and ready to go. So if you could briefly kind of just describe this path as well.
Yeah, so what happens is that once a match has been found, so we're using the acceptance feature, where basically both players have to opt into a match. And we've again chosen to make this transparent from the player's point of view. So what happens is a match has been found and both game clients are notified, okay, there is a match ready to go here. But the system, and by the system I mean sort of the right-hand box there, doesn't know if those game clients are still around. They may have crashed, they may have disconnected. There could have been any number of reasons of why they're not currently able to play the game. Yeah. So as soon as that comes back, the game client has a very short time period. I think it's something like 10 seconds to respond to say, yeah, hey, I'm actually around still, and I accept this match. I want to play. Some people may choose to actually throw a piece of UI up for the user that says, would you like to play in this match, or would you not like to play in this match? Yep. We opted to not do that, and we just say, okay, if the game client is up and running and can sort of is in a state where it can actually transition to the game, then we say, yeah, we'll accept this match, and we go ahead with it. That way, at least we know that way we can filter out any crashed game clients or anything like that, or people that have been here. And what happens there is that in that case, we basically just start a new matchmaking request for the other side. So the one side will kind of see their found match notification would pop, and they would see a spinning arrow for a little bit while, and then it goes back to finding match, just because the other side wasn't actually able to play in the game. Yeah, and again, that's one of those decisions that we wanted to let you as the developer make. We expose the API for match acceptance. You determine how you want to use that, if at all, like in your user flow. And again, we're just trying to make it as flexible as possible for you guys. And I think it sounds like you guys ended up with a pretty good landing place there. Yeah. Cool. So now for the fun part too, after getting to talk about all of the kind of deep dive on your architecture, let's talk a little bit about the success that you guys have had, both just from the game itself and from a AWS Amazon GameLift perspective too. So take us through some of these stats. Yeah, so the highest we've seen so far is about 6,000 concurrent users playing online multiplayer specifically. Yep. So a lot of people play offline only, but this is just peak concurrent online users. And because it's a heads-up game, that means that we've had roughly 3,000 game sessions going on at the same time. And this was one of the things that I think is kind of interesting about this entire thing. We're running dedicated servers for what ends up being a heads-up game. So we literally have an individual server process that gets spun up and runs on the piece of hardware somewhere so that 2 players can play against each other. And using this entire thing that was actually economically feasible for us to do, which I think is pretty cool.
Yeah, I find that pretty awesome, actually, because I think you guys are on Windows too, right? And so early on, Windows, yeah. So you guys just made the decision, hey, you know what? We're not going to put multiple processes on a host, even though GameLift supports up to 50. We're going to use Windows because that's what we're familiar with, even though Linux instances might be a bit cheaper. And it's worked out economically. I think one of those reasons, if I'm not mistaken, might also be attributable to the fact that you guys are using spot instances. Again, you guys kind of dovetailed nicely with a new feature launch for Amazon GameLift. Spot instances are a way that EC2 offers excess capacity for less, and so with the slight possibility that your game session could get interrupted. And what we've found is we can actually, through Amazon GameLift, kind of safeguard against that interruption possibility. And so what we attempt to do is never place game sessions into regions where there's been a recent interruption, to make sure that those spot instances are going to be live and available for your players. We see pretty low interruption rates overall, and the savings that you can get is up to 90% off of what a normal EC2 instance might cost. So have you guys seen like those economics then, like you said, work out for you?
Yeah, they've definitely worked out for us. And it's pretty seamless. So I mean, we kind of did the reference setup that you guys had suggested for how we should set up our fleet. So every region has 2 fleets running, one that's an on-demand and one that's a spot fleet. So and GameLift kind of figures out whether it's currently too dangerous to try and place a particular player session on the spot fleet. Most of the time, it determines that it's totally okay and it puts it on the spot. And if it doesn't, it just kind of seamlessly places it on the more expensive but more reliable on-demand fleets.
Right.
And as we're monitoring this stuff as the day goes by, like we definitely see sometimes it has to fall back to the on-demand fleets, but most everything is running on spot, which has been really great for us.
Yeah. And so that's I think a really good call out too, in that if your fleet does get interrupted and we aren't able to, for some reason, predict that interruption, if you have the on-demand architecture, your players still aren't going to be impacted, because those game sessions are just going to be spun up on the on-demand instances, and play can just resume as it normally would on the more expensive instance. But most of the time they're not going there, and you have capacity available in those spot fleets to get that discounted price. Yeah, cool. So the other thing that we're a little bit close on time here, but one thing that I did kind of want to point out too is that you guys launched your first multiplayer ever game simultaneously globally. That's pretty impressive, across 3 platforms. There wasn't a staggered launch. You didn't do Xbox One first or PC first, and this blows my mind. No user-facing downtime since launch. Looks like you guys might have had an accidental deployment on your side, but otherwise. That's pretty impressive for a small studio to be able to launch globally simultaneously on 3 platforms and have no downtime. Am I getting that right? Like that seems almost too good to be true.
Yeah, it's kind of crazy. I mean, it worked out well. There was definitely a lot of bullets that were being sweat on day one.
I bet.
So we ran a beta ahead of time, and we worked out a lot of the kind of in-game problems, like the multiplayer code made a lot of progress during the beta period. But what I mean by that is we were looking at those diagrams before. At one point, we just have a direct UDP connection to the server, and we're actually in like real-time multiplayer territory. And there's a lot of bugs that we got to fix there, but we couldn't get enough users. Specifically, we couldn't get enough users simultaneously to play in the beta to really stress the actual GameLift infrastructure. So when I was talking before about scale, like those are things we just couldn't really test. Like the scaling rules didn't really kick in until launch day. We hoped it was going to work, but it did.
Yeah.
And the other thing that's really cool about this entire thing is we've got the ability to patch with basically no downtime. So what we can do is when it's time to roll out a patch, so we try to keep all the platforms in sync. So we patch at exactly the same time. So we will have, Thursday at 5 o'clock, we're going to roll out all the patches to all the platforms. We schedule it all, and they go at exactly 5 o'clock. And as players pick up the game, their client automatically updates. But of course, there's still older clients that are currently playing multiplayer sessions and all this. So what we do is we basically spin up a second set of fleets. We've kind of got in the back end, in those diagrams that we were looking at before, that entire flow, we basically have multiple versions of this. We always kind of pass in like what what version that we're currently trying to use. And realistically, all we really do is toggle between two. One is the live one, and one is the outgoing one.
Yep.
But what we can do is we can just say, okay, a new patch is rolling out, so let's basically flip those two so that the current active one becomes the outgoing one, and the new one becomes the live one. And any new patched client just connects to the new backend, the new fleets, the new everything, and the outgoing clients are still connected to the old backend and the old fleet. And we just let that peter out and have the new fleets accommodate any new requests. So client facing, that means there's no downtime at all.
Yeah, that's awesome.
So we don't ever we have the ability, and we use it a lot sort of internal for development. Like I can set a switch in the back end that just says, okay, online is currently not available, but we've never had to use it.
Yeah.
It's basically just we do the live swap, and we can do that with server patches as well. So that's both client-side patches and server patches. So we've hot patched our servers numerous times. And again, it's totally transparent from the user's point of view. What we do is we just update our server fleet, point the live configuration at the new server fleet. Any existing clients that are still running on old server code, that just kind of eventually die out as the games conclude, and then new sessions are placed onto the new fleet. So that
sounds like
really cool for us.
Yeah, it sounds like it's been sounds like you guys have enjoyed your server experience here. So I'm happy that's definitely worked out for you. And then before we wrap up, one more slide here on just some more kind of overall statistics about Super Mega Baseball 2 on AWS. We've measured a median latency across your game sessions of 41 milliseconds, so under that 50 for median for just the normal course of connections, super fast. You have both spot and on-demand fleets running in 10 of those AWS regions. Sounds like you're rolling out patches to all platforms simultaneously, no downtime. You haven't had any issues with FlexMatch since you exited beta. That's great to hear. Hot patch server live again, without any real issues. And it sounds like even your DynamoDB table times as advertised are still constant with multi-million items placed in those databases. Is that right?
Yeah, Dynamo hasn't really been causing us any problems at all.
Nice.
I mean, other than the advertised things that you have to watch out for. But
yeah, sure.
Yeah.
No surprises there either.
Great. No surprises now.
Yeah. Before we wrap up, was there anything else that you wanted to call out specifically on this guy?
No, I don't think so. It looks like we've actually talked about most of these bullet points in the earlier slide already. Yeah.
Cool, man. All right. So with that, you guys decided to make the dive into multiplayer games as your most requested feature from your first game, and you chose GameLift. And I'm really happy that you guys did. It sounds like you guys are equally pleased with with latency, with cost, and the scalability of GameLift. And so if you didn't have anything else, I'm not sure if we have any questions. We're kind of at time, but was there anything else that you kind of wanted to add there, Christian?
No, I think the only thing that's worth calling out here for anyone that's listening is so, as you've mentioned, we're still running on a Windows backend. And we just did this because we develop on Windows. I mean, the platforms that especially Xbox is very Windows-like. Like, it was just easy to keep our dedicated server on Windows. And any of the costing estimates that we did, I mean, before we went down this path, this first thing I did was build a big spreadsheet to see okay, what is the cost actually like? Like, what are the targets that we need to hit? Sort of, how much bandwidth can we use? Like, what's actually feasible here, since you have to pay for both the bandwidth, like the outgoing bandwidth, and any EC2 instances to end up hosting the server processes. And the thing that we know, of course, is that Linux instances cost a lot less, especially the spot instances. When you're talking about the 90% cost savings that applies to the Linux spot instances. So if we're in a situation where suddenly the game becomes sort of much more popular than we had originally anticipated, that was always an option, is to just quickly try and port our server binary to Linux, which would basically save quite a bit of cost. And at this point, it's just, does it cost us more to port it to Linux, or is it cheaper to just pay the Windows server costs? So that's always an option that we have, which is pretty cool.
Yeah. If you guys wanted to drive those costs down even further, you could do multi-process or Linux for sure. So it does look like Robot Gandalf has a question. And his question, or hers, is there a good way to track the details about how the matchmaking rules are working and getting players into games? So yes, in the AWS console, we have a number of metrics that we've exposed. Christian, how have those worked out for you? Are you kind of able to track how your matchmaking rules are performing? We provide the kind of success metrics when a match has been successfully made via a particular rule. Are you guys finding that useful? Was that helpful in tuning things?
Yeah. So what we've done is we have a large. I can't think of it right now. Sorry, brain fart here. The tool where you can sort of graph all the stats.
Yeah.
On AWS.
Yeah, in the console. Yep. You're talking about the AWS console.
Yeah, but just the it's not CloudWatch, but it's using a lot of CloudWatch metrics.
Right.
Anyway, we kind of set up a console where you can graph all these stats. So like basically we have a large kind of dashboard set up to monitor all these things. And so yeah, we can live monitor exactly what's happening to our matchmaker, like how the individual metrics are actually performing, and we can sort of see what the average search times are. And the changes to that are pretty dramatic. I mean, as soon as when we were iterating on those rule sets that we were talking about earlier, of course our initial rule set where we saw where we let players of much larger skill play against each other, the search times were way down. And as soon as we upped that to our current rule set, we immediately saw, well, yeah, the average search times goes up, and you sort of see the individual components that make up the matchmaking requests and kind of what's happening with them, and you can monitor it in real time. So yeah, it's pretty cool.
Awesome. Well, that's good to hear too, that those metrics are working out. We worked hard to iterate on, hey, what are the right set of metrics to expose that you guys would be able to tune those rules as efficiently as possible. It looks like we have time for one last question here. Question for me, actually. I've heard that Bruce wears a kilt every day. Is that true that this man does not own a pair of pants? Well, users, sadly or excitedly, it is in fact true. I do wear a kilt every day. I'm a kilt wearer now for a number of years, and I don't know where pants are anymore in my house. So with that, I think if you don't have any other things that you'd like to add, Christian, we're going to call it a wrap. I really want to thank you for taking the time to, hey, you know what? Start out with trying out GameLift, working with us over the past year or more to make sure that this was a successful launch for your game. And it sounds like you guys are pretty happy with it, and we're thrilled that you guys decided to use the platform as well.
Yeah, thanks for having me on here. It was fun, and yeah, it's worked out really well for us. I mean, like I said, it was pretty scary to go down this route, and this part of the entire thing has worked out really well for us and hasn't really given us too much grief. So it's been good.
All right, with that, I think we're a wrap. Thanks to all of our listeners, and thanks again, Christian. I really appreciate it.
Yeah, thanks, Bruce.